Dear students, Namaskar. Myself S.K. Rajput. Today we will learn the topic haloalkane, haloarene, their preparation methods from chapter number 10, Organic Chemistry. Haloalkane, haloarene. Look here. This is haloalkane, chloromethane, otherwise methyl chloride. This new compound is called chloroethane, otherwise ethyl chloride. These two are primary, methyl and ethyl. This is called new compound. This is secondary, 2-beta carbon. This is called isopropyl halide, otherwise 2-halopropane. Last, this is called tertiary, 4 carbon, so this is called tertiary butyl halide, otherwise we can say 2-methyl propane. These all are haloalkanes on the basis of number of beta carbon, primary, secondary, tertiary. But this is called haloarene, just like bromo, benzene, chlorobenzene, but this is again haloalkane because this is cyclohexane. This is haloalkane. So today our topic is how can we prepare haloalkane and haloarene. I am writing a simple trick to remembering different methods. MAHAFILS. So there are different types method 1, 2, 3, 4, 5, 6, 7. So first you write the name of different methods. Look here. The meaning of MAHFILS is M stands for Markovnikov, A means from alkane, H means from Huns-Decker reaction, again A stands for from alcohol, Fi, the meaning of Fi is Finkelstein reaction, L means Leucos reaction, S means Swart reaction. First we start with Markovnikov and Kharas. These two reactions we already discussed in class 11. So revise. Listen. First is Markovnikov and Kharas. Markovnikov. Suppose this is CH3 CH double bond CH2. Its name is 1, 2, 3. This is called propene. Propene is asymmetric alkene. On asymmetric alkene, when any polar molecule, suppose we are using HBr, HCl, this is polar molecule, minus, partial plus. If reaction is happening in dark and reaction is happening in presence of sunlight, otherwise presence of peroxide. So the second reaction is called peroxide effect, otherwise Kharas effect, otherwise in dark this is Markovnikov. So this is called anti-Markovnikov. There is 3 names: peroxide effect, Kharas effect, otherwise anti-Markovnikov. And first is Markovnikov. Markovnikov reaction takes place in dark, and the negative part of polar molecule joint on that carbon atom where least number of hydrogen present. Focus on here. In double bond system, here number of hydrogen are less, here more. So in presence of sunlight, other presence of peroxide, this negative part joint on that carbon where number of hydrogen are more. Can you guess the product in these two cases? In first case, this type CH3 CHCl. This is a product reactant. Here negative part joint and the hydrogen atom of HBr joint here. So this is 1, 2 bromopropane, otherwise we can say this is isopropyl bromide. This is secondary category. But in Kharas reaction, negative part joined here. CH3, CH2, CH2 here, Br. This is one. So this is called bromopropane. Otherwise we can say normal propyl bromide. This is category of primary. So these two are Kharas reaction and Markovnikov reaction. After the reaction, different type categories of RX are formed, secondary and primary, based on presence of peroxide or light, otherwise in dark. What was the second heading? That our trick was Mahfils. MAHAFILS. The second. Second means alkane. Alkane. What are alkane? Alkane are saturated hydrocarbons, just like methane, direct reaction in sunlight. So all the hydrogens of methane replace one. First CH3Cl, removal of HCl, again chlorine, CH3Cl2 form with minus HCl, again chlorine, here CHCl3 form, again chlorine, and last CCl4 is formed with removal of HCl. In this reaction, this is methyl chloride, this is methylene chloride, this is called chloroform, CaCl3. Other we can say trichloromethane. This is carbon tetrachloride, tetrachloromethane. So in this reaction, the mixture of all these are formed. This is not perfect or accurate method. If we use this type, larger alkane, CH3, CH2, CH3, its name is propane. This is alkane, propane. In propane, there are how many set of equivalent hydrogen atom? Equivalent means identical hydrogen. These CH3 and these CH3. These two are form same set of equivalent hydrogen, and this is different. So according to number of sets of equivalent hydrogens, product form as the number of different sets. If there are two sets, these two are identical, this is different. So two product will form. If there are three sets of equivalent, three product will form. Four product will form. In this reaction, 1, 2, 3. If chlorine, otherwise any halogen after the reaction, join here, otherwise here. After filling hydrogen, you can say this is chloropropane, otherwise normal propyl chloride. If chlorine join here, you can say 2-chloropropane. So two products are formed because their name are different. After filling hydrogen, this is 1-chloropropane, this is 2-chloropropane. Work for you. If chlorine react with this compound, can you guess name of this compound? This is 2,2-dimethyl propane, otherwise this is neopentane. So in neopentane, all these 12 hydrogens are equivalent. So after the reaction, only one product will form. Can you guess how many products will form in this compound? Can you guess? Homework for you. First off, identify number of sets of hydrogen atom. For nomenclature, we can start here 1, 2, 3, 4, 2,2-dimethyl butane. Work for you. How many products will form when chlorine react with 2,2-dimethyl butane on the basis of number of sets of equivalent hydrogen atoms. Next, according to trick MAH. H means Hunsdiecker. The third one reaction is Hunsdiecker. Most important reaction, Hunsdiecker reaction. Hunsdiecker reaction. Listen. To remember Hunsdiecker reaction, I am writing a trick. Ra Hunsdiecker. Listen, the meaning of this is the homophone of Hunsaker. Hunsaker, Hunsaker. Here, the meaning of this is R. The meaning of Ku is COO. The meaning of Sa is silver. This Sa stands for silver. So we use silver. This is called silver salt of carboxylic acid. Here, this D. D means dihalide. Dihalide means we can use dichloride, dibromide, but not difluoride, not diiodide. If we are using dichloride, then and this Ka stands for CCl4. CCl4 used as a solvent and R for reaction. So for Hunsaker reaction, we can say the reaction in which in presence of CCl4, chlorine or bromine react with silver salt of carboxylic acid. Actually, this is called carboxylic acid. Suppose, for example, this is CH3COOH. This is what? This is acetic acid. In acetic acid, if we replace this hydrogen by silver, then what will form? CH3COAG. This will form silver acetate. Silver acetate. So after reaction, listen, this AgCl will form AgCl. Okay. This whole circle matlab CO means CO2. The CO2 gas will liberate. And what are the product? This R and one halogen. This R and halogen will form. Remove. By removal this carbon in the form of carbon dioxide, total number of carbon decrease. So this is called carbon degradation reaction. In carbon degradation reaction, number of carbon decrease in product. This is also called descending the series. Listen, suppose this is silver acetate. In silver acetate there are two carbon, 1 and 2 carbon. By reacting bromine otherwise chlorine in presence of CCl4, then AgBr CO2 and what will form? CH3Br. So in this product there is one carbon. In reactant there are two carbon. Listen. In this reaction, instead of R, you can also use ring, means aromatic compound also form. But in this reaction, we can't use fluorine because fluorine is highly reactive and its affinity for hydrogen is very well. And iodine, if we use instead of chlorine or bromine iodine, then ester will form. No will form ethyl chloride, ester will form. So in Hunsaker reaction, we use chlorine or bromine with silver salt of carboxylic acid in presence of CCl4 and haloalkanes are formed. This is called Hunsaker. We have written Hunsaker. R means alkyl. Instead of alkyl, we can use aromatic ring, means benzene. Cu means COO. This is carboxylic ion. And Sa stands for silver. D means dihalide, dichloride, dibromide. So next, our trick was methyls. MAHAFILS. So now this fourth, A for alcohol. This is ROH, fourth method, alcohol. ROH is alcohol. Listen, alcohol. So if alcohol react with PCl3, alcohol react with PCl5, otherwise alcohol react with SOCl2. SOCl2 is called thionyl chloride. PCl3, PCl5, otherwise thionyl chloride. ROH. So PCl5 when react with this, in all these RCl will form. And can you guess side product? In first reaction, when PCl3 react with this, there we use 3 ROH. 3 ROH and D. So 3 chlorine react with 3R and form 3 RCl. What is remaining? Single P, 3 hydrogen, 3 oxygen. Form H3PO3, phosphorus acid. But in case of PCl5, it's 5 chlorine used. First chlorine here, another chlorine with hydrogen, and what is the remaining? Remaining oxygen and P with 3 chlorine. Phosphorus oxychloride also formed. These are side product. Sulfonyl chloride with reaction sulfur SOCl2, its first chlorine used here, another chlorine for HCl, and remaining, what is remaining? Oxygen and sulfur. SO2 gas is formed. This gas liberate to absorb HCl. In this reaction, we use pyridine. Pyridine is a compound which absorbs this HCl. Pyridine. And this reaction is called, last reaction called Group's reaction. Last reaction of SOCl2 with alcohol in presence of pyridine. Group's reaction. Listen. In all these reactions, we use chlorine. No fluorine, no iodine, no. Fluorine is highly reactive, so we can't use. But why we cannot use bromine or iodine? Listen. Bromine and iodine, if we are using here bromine or iodine, then these all compounds means PBr3, PBr5, SOBr2. These all are compound are very unstable. In case of iodine, too much unstable. If you want to form iodo otherwise bromo compound, then numeral ROH. Here we use red phosphorus along with X. This X may be chlorine, bromine or iodine. So these two react and form PCl3, PBr, Pi, PX3. So reaction of these two, red phosphorus halogen gives PX3. X may be any type of halogen, bromine, fluorine, iodine. These two react and form PX along with H3PO3. RH. This is alkyl. Here X may be chlorine, bromine or iodine. So remember, to prepare iodo otherwise chloro otherwise bromo alkane, we use red phosphorus along with X2 for reacting alcohol. Listen. If we want to chloro, fluoro or bromo, there are new different techniques. Listen. Suppose this is RX. From RX we want to prepare RF, otherwise RI. Here X may be chlorine or bromine. Listen. We want to replace halogen by fluorine or iodine. If we want to replace fluorine, we use AgF. This is silver fluoride. For this reaction, we use NaF. This is sodium iodide. Ag. Here NaX. Here AgF will form. First reaction is called Schwarz. This reaction is called Finkelstein. These two are halogen exchange reactions. So listen, how can we remember these reactions? Listen, I am reacting, change one letter, Schwarz, you use Schwarz. So this S stands for silver and F stands for fluoride. So from reverse, the meaning of S and F, silver fluoride. If we are using silver fluoride, reaction is called Swart reaction. If you use here double A and in reverse, the double A meaning is this. A means acetone. In this reaction, we use here acetone, CH3COCH3 as a solvent. And remaining is NaI. So NaI meaning this is INA. In reversing, you can write NaI. So in Finkelstein, at last we use double A. In detail, I am writing here again. Listen. Suppose Rx, this X may be chloride, otherwise bromide. We want to replace fluorine. So we are using AgF. This reaction is called Swart. But what change we write here F. So Swart. S stand for silver and F stand for fluoride. So this reaction AgX, after AgX, RF is formed simply. Instead of AgF, we also can use this compound AgCl, otherwise AgF. This is called mercurous fluoride. It exists in a dimer form. So after the reaction, this 2HgX and RF will form. This reaction also called Swart reaction. In Swart reaction, we use silver fluoride, otherwise mercurous fluoride. If we want to replace more than one halogen by more than one fluorine, we use a new compound SbF3. SbF3 is antimony fluoride. Suppose antimony fluoride is reacting with CCl4. CCl4 means carbon tetrachloride. In this reaction, this antimony fluoride replace 2 chlorine from that compound and form SbCl3, and here CCl2 along with F2. This compound is formed by help of this 2 chlorine replaced by fluorine. This compound is called difluorocarbon. This is also called freon. So in exam they ask how can we prepare freon. Freon we can prepare by reacting CCl4 with antimony trifluoride. These all three reactions are called Swart reaction. In Swart reaction we can use silver fluoride, mercurous fluoride, otherwise antimony fluoride. In Finkelstein reaction, we have written what? Finkelsteina. Finkelsteina means Finkelstein. So we write here in last IN double A. It means A means acetone in last, from last acetone. In presence of acetone, this is acetone, CH3CO and CH3, this is acetone, and this remaining NaI means NaI. Here NaI react with Rx, X here may be chlorine, otherwise bromine. Listen, this halogen iodine replace this X here for Ri means iodoalkane along with NaX. This NaX may be sodium chloride, otherwise sodium bromide. The concept means principle of this reaction is that NaI means sodium iodide is soluble in this liquid. Acetone we use to dissolve sodium iodide, but the product means sodium chloride and sodium bromide do not dissolve in this compound. So the concept of Finkelstein reaction is that NaI we dissolve in acetone, it is able to replace this compound. So in next What is our topic? Topic is Mahfuz, means Markovnikov, alkanes, Hunsaker, alcohol, Finkelstein, and last was what? And the second last is L. L stands for Leucos reaction. To remember Leucos reaction, we are writing Zeucos. Listen, the meaning of Zeucos. Listen. Here the Z stands for zinc. In reaction we use zinc, otherwise zinc chloride. This should be anhydrous. Anhydrous means without water. C means concentrated. A means acid. The concentrated acid which you use, that is HCl. And S in Hindi, S sa, and sa used for sarab. Sarab means alcohol. So we start reverse. Alcohol is reacting with HCl, HBr, any compound in presence of zinc, otherwise zinc chloride. Then what will happen? Very simple. This reaction is called Zeucos, otherwise Leucos reaction. This H water molecule will form along with RCl. Listen, in this reaction, instead of R, you cannot use aromatic ring because aromatic ring form here partial double bond, and these are least reactive toward this reaction. So in Leucos reaction we can't prepare chloro, otherwise halo benzene from alcohol. We use only RH. But this R, according to R, their alcohols are three types: tertiary, secondary, and primary. The tertiary alcohol gives this reaction very fast. If we are using tertiary, do you know meaning of tertiary? Here CH3, 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 C, and OH. These three methyl groups, due to plus inductive effect, increase the reactivity, and after the reactions Cl, in tertiary case the reaction is so fast. So fast means the catalyst is not required in this case if we are using tertiary. So after the reaction, CH3 whole 3C Ca along with water will form. Very fast reaction. So the mixture of Rx and water, this gives turbid solution. Turbid solution means hazy solution. So according to primary tertiary gives this reaction in very microsecond, few minutes happen in this reaction, but primary give this reaction in hours, otherwise no reaction. So according to formation of turbid solution, on the basis of time we can distinguish different types of alcohol. If turbid solution comes very quickly, alcohol is tertiary. After some time, secondary. No reaction, otherwise very long time, primary. Listen. So this is called Leucos or Zeucos reaction. In alcohol we are converting into this compound. Listen. One more thing. The reactivity depends in these two. R should be tertiary, and for HX, the HX means HCl, from HCl the greater reactivity of HBr and higher reactivity of HI. If we are using HI and tertiary, very fast reaction will take place. So this is the meaning of Markovnikov and Karas, alkane, Hunsaker. This is alcohol. This is also alcohol reaction, but this is separate Leucos reaction. Finkelstein, Leucos, and Swart reaction. Now, the last. How can we prepare aromatic compounds? Aromatic means with ring. If we want to prepare X means halo alkane, halo arene. There are two simple method, D and D. First is direct halogenation and second is diazotization. What are the meaning of these two? First, direct halogenation. Direct halogenation means, listen, this is benzene. We are reacting halogen, direct halogen. Suppose chlorine, direct chlorine. Case may be 2. Reaction is happening in dark with in presence of catalyst. Suppose AlCl3. This is anhydrous aluminum chloride. You can also use FeCl3, anhydrous FC. Otherwise, reaction takes place in sunlight, presence of sunlight. In dark, this chlorine replaces this hydrogen and form chlorobenzene. But in light, this chlorine joint on each carbon atom form this type. Can you guess name of this compound? The benzene is C6H6, but this compound is C6H6Cl6. Here in this reaction Cl2. This is called 666. In class 11 we have studied 666 is called gamescane, otherwise linden. This is insecticide, but this is called chlorobenzene. If instead of CH you are using CS3, this is called toluene. Then what will happen? If toluene react with chlorine, listen, this is toluene. Reaction may be 2 types. Number first, in dark in presence of catalyst, anhydrous AlCl3, otherwise in presence of sunlight. In dark, do you know the directing effect of methyl is ortho and para. This chlorine, according to in effect of ortho and para effect of methyl group, 2 product will form. In first, chlorine joint on ortho, in second, chlorine joint on para. So this is called 2-chlorotoluene. This is called 1, 2, 3, 4th chlorotoluene. The mixture of these 2 form. But if reaction takes place in sunlight with toluene, with chlorine, what will happen? Chlorine replace hydrogen from CH3. The substitution reaction takes place this type. Here, from toluene, 1 chlorine replace. Can you guess name of this compound? This is called chlorophenyl methane. Otherwise, we can say this is called benzyl chloride. If reaction takes place again in sunlight, 1 HCl again replaced from here, H and Cl. Again 2 chlorine directly jointed with this carbon. Can you guess name of this compound? This is dichlorophenyl methane. You can also say this is benzyl chloride. And last, this last hydrogen replace in last step and form these 3 chlorine directly with carbon with this. You can say easily name of this compound. This is trichlorophenyl methane. Otherwise, this is called benzyl chloride. Benzyl chloride. So this is called benzyl. This is called benzyl. This is called benz. So these are direct halogenation reactions of benzene and toluene. The last is diazotization. The meaning of diazotization. Diazotization. Very important question. Diazotization. In diazotization, a compound is formed that is BDC. The full form of BDC is benzene diazonium chloride. So benzene, this is benzene, and this one is diazonium. Diazonium means N double bond N, and last there is chlorine. You can observe I am writing this compound in 3 different colors. This compound and last. So This is benzene, this is diazonium, this is chloride. Listen, this part of BDC come from aniline. This is aniline. Aniline means benzene ring along with NH2. This nitrogen comes from this compound. Can you guess name of this compound? Actually, this compound is HNO3. Sorry, HNO2. This is called nitrous acid. To prepare nitrous acid, because nitrous acid is unstable. So to prepare nitrous acid, we use sodium nitrite along with HCl. These two react fast and gives HNO2 and NaCl. So in exam, sometimes they ask instead of nitrous acid, they can write mixture of these two, because these two reactant are using to prepare nitrous acid. And one, this H, this chlorine comes from HCl. So these three compounds are used to prepare BDC: aniline, nitrous acid and HCl. Water molecule from here, two water molecules are removed, and what will form? This ring, nitrogen and chlorine, means this is called benzene diazonium chloride. And this reaction happen at 0 to 5 degrees Celsius, very low temperature. This is white color crystalline compound. So this reaction is called diaphysism, and this is also used to test aniline. Aniline gives this type compound. So the question is, how can we prepare different types haloarene by help of BDC? Listen, this is benzene diazonium chloride. First, if we want to prepare fluorobenzene, then we use this type simple compound HBrF4. This is called fluoroboric acid. Fluoroboric acid react with HCl first and form this type compound, N2 plus BrF4 minus. This type ionic compound is formed. Due to resonance, this is most stable compound. So in solid state, as an intermediate compound, this is formed. On heating, BF3 from here and N2 from here remove, one fluorine left. This fluorine directly connected with ring and our fluorobenzene is formed. So in exam, if they ask how can you prepare fluorobenzene, two simple methods. BDC react with fluoroboric acid, form this compound. On heating, it gives fluorobenzene. If we want to prepare iodobenzene, very simple, we use reaction of Ki in warm water. This K replace chlorine KCl N2 N. This iodine of Ki directly jointed with what? Ring. This is iodine. Very simple. These all fluoroiodohalobenzene are formed in pure state. So this is very useful method from BDC. This is BDC, benzene diazonium chloride. Next, listen. If in presence of copper, this is copper metal. If in presence of copper, we react BDC with HX. HX means hydrogen halide. This hydrogen and this chlorine remove as HCl N2N. This halogen joint here. Listen. Here X may be chlorine or bromine, not iodine. This reaction is called Gatterman reaction. In Gatterman reaction, in presence of copper, HX react with BDC form halo benzene, chloro otherwise bromo. Listen, if we are reacting CuX with HX, in these two X should be similar. In presence of this, we are reacting CuX is cupric halide. Then in this reaction, CuCl along with N2,4 and X, these two reactions are similar. Last reaction is called Sandmeyer reaction. What is the difference between these two? In Sandmeyer reaction, copper is catalyst. In Gatterman reaction, copper is catalyst. Reacting species is HX. But in Sandmeyer reaction, in presence of HX, CuX react. In these two, we can use X as a chlorine or bromine. So after this reaction, we can observe that fluorobenzene, iodobenzene, chlorobenzene, bromine, all type are haloalkane are formed by help of BDC. So thank you for watching. Namaskar. Stay safe.